So a warm welcome to everybody to the webinar, How Hinges and 3D Printing Improve the Smart Performance. It is our second webinar about hinges and technology behind this new exciting segment of eyewear. And we are pleased that we had more than 100 registrations from many countries all over the world. We, OBE, with the two Franks, are the hinge guys, showing you solutions relating to the articulation of smart glasses, specifically the temples. But we are not alone. I'd like to welcome also the two Daniels, who will report about the additive and manufacturing technology and how this innovative production method matches with the world of smart glasses. And I would like to thank you already for participating to our webinar as speakers. One organizational thing, as it was reported, all participants are muted beside the speakers, and you can interact with us via chat. All the questions, or depending on the time, will be answered at the end of the webinar. So let me introduce myself. My name is Frank Schröder. I'm in charge of the marketing at OBE. And I've been working since 1997 in this company. So I'm celebrating this year my 25 years. And why I've been working so long in the company? I think the main reason is that OBE is a company which always tries to be ahead of important developments, such as spring hinge technology, titanium, but also ahead in internationality. And now the target is to be a major player for smart eyewear components. So maybe you can introduce also yourself, Daniel Miko.
Hello, my name is Daniel Miko. I'm one of the co-founders of Umabo. We founded 2015, and since there we are on the market. I have more than 10 years of experience in eyewear business and also eyewear design. I'm responsible mainly for the product development and the design. So I'm the head of design. And I would say we as Umabo and we brought customized eyewear and 3D printed eyewear from the idea to a reality, and wanted now to bring it more to the world.
Then I say hello from the other Daniel Lichtenstein. It's a pleasure for me to be here with you today. I represent Additive Scale. Additive Scale is a company that actually belongs to Umabo. It's part of the Umabo group. And what we do, we basically have revolutionized how we can do 3D printed eyewear. So we operate one of the most modern 3D printed factories based in Munich. I'm responsible for the growth of that company. My background is I'm a business person originally, but having worked especially in the 3D printing industry for more than 10 years, always looking at from a machine side at the market. And in recent years, I'm very glad to be part of this endeavor of bringing 3D printed eyewear to the world. So hello from my side.
Hello.
And the fourth, last but not least, hello from my side. My name is Frank Wienicke. I'm an engineer for micromechanics, and I work for OBE since 23 years now in the R&D department. I also co-hosted with the other Frank last year's webinar, and I'm glad to be here.
So let's go briefly to the introduction of the company. So something about OBE. We were founded in 1904 as a company for the jewelry tools in the northern part of the Black Forest, which is also our headquarters in Germany. And from the beginning, we were also orientated to precision components in metal. In the 1970s, we started to concentrate our business to the eyewear sector, particularly to hinges and screws. We equip today more or less about 50 million frames per year with our hinges, and about 100 millions if we count also the screws. We have worldwide about 500 employees, 200 in Germany, and about 280 in China, where we have also another facility since 2004. Additionally, we have subsidiaries in Hong Kong, China, and Italy. and worldwide representations. And we are sustainable already since 1996, when we implemented our environmental management system. Since then, we reduced the consumption of energy, water, waste, and auxiliary materials considerably each year. And since last year, we have implemented also a carbon footprint goal, and we aim to be carbon neutral by latest 2040. But let's talk about the frames. And let me start with two major factors which are essential for a frame, no matter if we talk about standard ophthalmic glasses, sunglasses, reading glasses, or smart glasses. It is the comfort. In fact, if the frame doesn't fit properly, we feel uncomfortable. One major aspect of comfort is the weight. And of course, the more grams we are wearing on the face, respectively on the ears and nose, the more the construction which will be maybe disturbing. And of course, it is the goal always to be as light as possible. So here we can see a range of spectacle types, from reading glasses to large sunglasses and smart glasses. The weight of the lightest version starts about 9 grams and ends in standard frames about 100 grams. This is equivalent to 10 strawberries. If we talk about smart glasses, we are of course in another weight category. We can compare it to the major boxing glass, the heavy weight. Here we can reach in the frames easily 200 grams, so 20 strawberries. This is of course due to the installed electronics, acoustics, sensors, and lenses. Briefly, all inner components which make the glasses being smart. From the hinge side, we can contribute to the comfort on two sides. If the frame is super light, we have the guarantee we have to guarantee a certain stability in this fragile construction. In wider frames or bigger frames, we can contribute with spring hinges to diminish the pressure on the wearer's head and therefore to create a better comfort. Another key aspect of spectacles after the comfort is the articulation. We as a hinge manufacturer develop long-lasting hinges. It means the hinges should perform, depending on the material and function, minimum 25,000 to 50,000 cycles. In the case of 25,000, we can estimate an endurance of about 7 years if we move both temples 10 times per day, for instance. The movement in smart glasses gets more and more important, as these types of glasses should fulfill the same function as standard spectacles in the use, also being maybe put in the case. One important aspect regarding smart glasses and hinges is if the construction of the frame is similar to an ophthalmic or sunglasses, and if the smart function is positioned only in the temples and not transferred to the front, then it is possible to use all kind of standard non-flex and normal hinges and flex hinges in the smart glasses, as they contribute to the comfort and articulation. We recommend to use in these smart glasses flex hinges, and those which can be implemented in the temple by a screw. We have a couple of solutions which was the topic of last year's webinar, and please contact us if you need any more details in the standard production.
In this webinar, we are concentrating on the smart glasses, which are designed with a data transfer between front and temple. In fact, we see this is a trend in this market segment. With this feature, in fact, it is possible to connect a display, a camera, or sensors in the front with the electronics positioned in the temple. Or it is possible to lead the power from the battery in the one temple to the CPU in the other temple. Or you also can finally synchronize 2 audio modules in each temple. This data transfer can only be done with a kind of cable. This is why we talk in this situation about a cable feed through, and as a result about a necessary movement and articulation in this area. The cables which are commonly used in the wearable electronics are FPCs with a thickness of starting from 12 microns and can reach up to 0.8 millimeters, depending on the flexibility and the number of layers. The width, in fact, depends very much on the number of signals to be transferred in parallel, and the amount of electric power. On the other hand, also common ribbon cables can be used, as you can see on the bottom picture, with a cross-section of 0.1 to 0.3 square millimeters per wire, which means a thickness of approximately 0.7 millimeters, including the insulation. So these are important features to consider for the hinge to be used between the temple and the front of a smart frame. The challenge is now how to bend this cable without any damage and with no elongation problems inside the channel. In fact, if data is transferred between temple and front of the smart glasses, and at the same time we like to have a normal articulation and wearing and handling comfort, we need a special hinge construction. As you can see on this picture, we on the projection of on the glass, the user has a problem with the data transfer. The signal is not transferred properly. But we didn't call Houston in this case. The transfer of the signal in the smart glasses from the temple to the front is a challenging topic, especially in the opening and closing function. The cable inside is stressed. The result can be a misfunction of the smart glasses, referring to the signal handling. First of all, we have a positioning and location problem of the cable. It is quite impossible to put the cable in the middle of the hinge axis, but only in this middle position, the so-called neutral fiber, the length of the cable remains constant in any position of the hinge. Unfortunately, this ideal situation is not feasible to realize in most cases. So since this is not possible to feed the cable or the ribbon cable or the FPC through this neutral fiber, a buffer area is necessary to compensate the change of length during the articulation. As a result, we have to face a cable elongation due to hinge movement. This elongation has impact on the hinge. It is as it is necessary to cope with the longer cable inside the channel. Here you can see the picture that the cable path gets longer during articulation. So seeing it drastically, this is what could happen in the wearing position. The cable is too long, and as a result, the cable might get tangled. And as a consequence, it's possible for the cable to be damaged, which impacts misfunction. On the other hand, in the folding and or closed position, the cable might be too short, which causes stress and also a possible damage and rupture with transmission problems too. To compensate this existing cable elongation, we need an extra zone for the cable, a so-called buffer area. For sure, due to the essential reasons, this zone should be as small as possible. Otherwise, it would have a thick area in the end piece, which would influence also the weight of the frame, what Frank also mentioned before. We evaluated this problem and calculated the optimum physical length for each position of the foldable temple. So here you can see the wearing position and the exact amount of buffer area, which is shown in the wave of the cable on the front and on the temple side. The conclusion is a kind of bridge hinge, which is needed to overcome this extra length of the cable. And this is how the SmartLink was born. The SmartLink, in fact, has been designed with the necessary cable channel to feed the cables, to feed through the FPC or the ribbon cable. And the key factor of this product is that it enables an optimum cable length, no matter in what position the temple is, open or closed. In the open position, the cable is allocated naturally in its track thanks to the slit in the hinge. The curved construction of the SmartLink prevents a cable tangle. And by closing the temple, normally a hinge moves one time 90 degrees. The SmartLink divides this articulation by 2. So we have a movement of twice 45 degrees. The SmartLink fulfills a double hinge function. Again, here the optimum cable length is reached during the articulation. The cable elongation is minimized to a maximum. As a result, the cable is not stressed and cannot be damaged. Additionally, a smooth cable routing and large radii prevent the electronics from damage.
All the described features directed the manufacture method of the SmartLink to the metal injection molding, which we have in-house since 1998. It is a production method to produce especially complex geometries, and especially the curve construction here is ideal for our technology. So just 2 slides to explain the MIM technology. In the first step, a metal powder is mixed with a binder. The so-called feedstock is then injected in conventional injection machines. This process makes it possible to create extremely complex geometries, which in conventional production method could not be reached. After injection, the so-called green parts are transferred into a debinding oven where the most part of the binder is eliminated. In the last step, the parts go into a sintering oven and shrink about 20%, so the amount of the binder which was inside the feedstock. In this process, the rest of the binder is also eliminated. So at the end of the process, we have 100% metal part without any plastic parts inside. One thing which we would like to point out is that the MIM production is a waste-free production method. After the injection, the non-necessary sprues are reused again. They are regranulated or repelletized to become feedstock again. So the MIM process in this case is extremely resource-efficient production method. And after this excursion of MIM, the bridge to AM or to 3D printing is perfect, as it is a technology with similarities, but also differences. Therefore, I'd like to pass over to the two Daniels and the section of 3D printing. Enjoy.
So I want to welcome you again, and yeah, let's go deep, or let's dive a little bit into the 3D technology and also why we use it for eyewear. So first, let's do the next. It's working. Now, yeah, how we get there. So we founded our company 2015. And we're a luxury independent eyewear brand, and we are a market leader for 3D printed customized eyewear. We are exclusively sold by independent eyewear stores globally, and foundation of our success, I would say, is our unique combination of design, technology, and also the mass customization. So we are, with our system, what we can explain later, are able to do a mass customization. And for that, we need 3D printing. And so Daniel, you can explain a little bit about additive scale.
Yes, happy to do so. So basically, Additive Scale was founded in 2021 because Umabo had a lot of demand. They were quite successful in basically selling it over independent stores. Therefore, we established a company that's fully focused on providing 3D printed eyewear at the beginning to Umabo, but now also to the market. So basically, what we've done, we developed a proprietary process that starts with 3D printing, but what happens afterwards is actually the magic. So today we get a very good quality. We will also see later some parts, and we can basically deliver from one unit, because 3D printing, you can very quickly also provide a prototype. But the purpose of this company is really, it's called Additive Scale, to scale into millions. Today we can do from 50 going into 100,000 units per year. But we are now basically looking at really scaling up this, because it totally makes sense, as you could see in the next current slides. And I think also important to mention, it's modern, sustainable, and I think, Daniel, you will now say a few words why this all makes sense.
Yeah, why 3D printed eyewear? I think we're solving with it a lot of problems what we have with eyewear. First of all, we have a lot of freedom of design. This means we have unlimited possibilities of design possibilities, from structures, from hinge mechanism, from what you can imagine with structures. Also, like I think that the well-known is a sphere in a sphere, or like helix structures, what you cannot do with the existing milling or ablative processes. Also, we have the I think for us at the first, it was the customization. We can produce one standard frame, but we also can produce a customized frame. So for the machine, it doesn't care about what kind of files you will feed it. Also, we have a 30% lightweighter than acetate. This is also a big thing for the wearers, that it have to be really light. So our lightest frame is about, it's like an A4 page, like 4.5 grams. Also, what is really nice to say, we can produce on demand. That means we can produce only what we need. So we don't waste that much things. Because in the The standard productions, you have to order big batches, you have to wait a long time for them. So we can also go really, really quick to the market. That means we don't have that long terms of design cycles and so forth. This is a really huge thing. We are 3 times more sustainable in CO2 footprint compared to traditional acetate production. And in the world what we're living now is sustainable at a really, really big point. As Daniel said before, we are scalable. So from 1 to more than 1 million units, we can scale up the production really easy. And we have the durability, which is also really good. We're really flexible and non-allergic material. So it depends on PA12 or PL. So this is the polyamide powder what we're using. Now we will show you a little bit what we do in 60 seconds.
This is a story about you, your face, your vision, the way you see the world, and the way the world sees you. We create the green eyewear industry of the future today. No mass production, no mass waste, with sustainability and reusability built in our DNA. Because any business destined to change the world must also protect it. This is the place where eyewear manufacturing is being transformed, thanks to state-of-the-art manufacturing technology, because of which we are able to combine technology with design and a seamless user experience. A totally new way to manufacture eyewear, resulting in a new level of efficiency and unlimited possibilities. Every pair is made to match a precise scan of your face using engineered facial mapping technology and manufacturing from durable, lightweight material, all made in Germany. This is you. This is your story. This is UMAO.
So as you have seen in the video, we have a really unique and a really modern technology to make eyewear. I think this is a really totally future thing. So now Daniel will explain a little bit about the technology. He's the best to do it. And I give the words to Daniel.
So thank you. Yeah. So as it says here, we are using SLS 3D printing technology. And I mean, if you look into 3D printing, there are a lot of abbreviations, a lot of different words. We heard before about cold metal fusion. So long story short, laser powder bed fusion, selective laser sintering, this is what we use. And we looked at the market very closely, and what we see is that this technology for now and the foreseeable future is the best technology for eyewear production. The reason why it just offers the most durable quality. So you saw that UMAVO was founded 2015, some years ago. The proof of product since then, I mean, they launched basically printed eyewear based on SLS technology. And since now the product works. It's a product that's long lasting, robust, and I think this is important. On the other hand, I also saw in the audience a question about the cost. We can have most competitive cost with this technology. And I don't want to say a number at this point. I'm happy to go into more detail, but we can really match also the cost of high quality acetate or other production with our 3D printing technology. And I think last point, it enables scale up. And I think this is a lot of risk in some technologies, but what we have showed that we can really now scale up from 50,000 to 100 and also to millions of units. And I think this is important. So SLS, again, we use polyamide powder. In detail, it's called PA12. PA12 is the powder we are using. It's melted with a laser beam. You maybe saw one of these machines. So that's a core machine where you see down here, basically layers of powder, which you melt with a laser, layer by layer, couple thousand layers. And at the end, you have then the 3D printed raw eyewear. We are using this frame then, and we have some other processing steps, especially since we are building this in powder. We need to remove the powder. There are some tumbling processes. There's the coloring process. And we do also some tweaks to the surface that it gets a very smooth, a very homogeneous surface at the end. Also, We are constantly looking at other technologies. There are some interesting things happening out there. So one element, for example, is SLA. It's like transparent material. FDR is fine detail resolution for SLS eyewear. So basically these technologies is what we monitor, but for now we can say this is the core technology for 3D printed eyewear. Maybe we can go to the next slide. And I mean, from theory to the practical life, I mean, this is a picture of our factory. You see there's still some more space. You see basically 4 printers, 4 production printers. And on the right, you see one of these FDR printers, kind of the next generation to have more details. So this is kind of the core of the factory that we use. And we believe it's the most advanced and most sustainable eyewear factory. We build everything with having nature in mind and having very, you know, basically from generating from the electricity, from generating pressed air and everything is made with a very sustainability in mind. And again, the factory is made for printing up to 1 million units if it's fully equipped with machines. And you see basically there's some doors into some other rooms. So besides the printing, after the printing, the other processes as mentioned follow to have then a fully finished, customized, perfect fitting frame. Maybe next slide. So the economics of 3D printed eyewear. And I think here it's quite interesting by looking at cost again. So our assumption is that if we launch, let's say if we launch smart eyewear, we can introduce the aspect of customization. So basically, if we compare 3D printing with other technologies, mostly injection molding or acetate, I mean, for other polymer technologies, we see that the cost today, maybe it's a bit higher, a few % compared to acetate. If we have certain volume, as said, we have definitely comparable cost. Injection molding, if you have serial production, fully optimized, large volume, of course, we can get very competitive prices in injection molding. But for sure, as soon as we do some customization, we see that actually 3D printing is a really technology that makes sense, because then the cost actually don't really go up. There might be from a process cost, we need, you know, some more, we need to attach some tags and do some special tweaks. But long story short, 3D printing is really a technology where customization makes sense, where in other technologies it doesn't. I don't want to go through all the details on the right here, but we see that a lot of the aspects that were mentioned at the beginning that is important, the personal fit. We talked about the geometry, the freedom of design. Basically, we can do a lot of elements, and Daniel, the other Daniel, will show at the end what this means for smart glasses. So we believe that by looking at smart glasses, 3D printing is really a technology to consider because it matches a lot of the criteria we have.
Yeah, coming back to the eyewear and especially to custom eyewear and also to the possibility for the smart glasses. So as you all know, we humans are all completely different. So everyone have a different size of the head, a different temple length possibility or need, or we're all completely different. So we have 2 eyes, a nose, but it's all on everyone different. So for that reason, we would say everyone needs at the end to have a really good and a comfortable fit, a custom eyewear. For the customization, we have 13 parameters, so they're the normal parameters for what the eyewear or also what the adjusting of eyewear is needed. We have like the bridge width, the size of the frame, the pentoscopic angle, and also temple length. So these are, I would say, the main factors you all know. And to optimize all these things, as you have seen in the video before, we make a 3D scan of the face and attaching the frame in a virtual try-on, in a real world try-on. This means the the frames are matching on the scan in the real size, and then you can adjust all the details, and then we can produce the frame. Also, this is for the future. If we're thinking for smart eyewear, 1 or 2 or 3 standard models will not fit everyone in the world, or will not fit every people. So we need more possibilities. And for our technology, we can, and also for the smart eyewear, we will use this technology for the future, because we can so good and so easily and cost efficient and produce the frames for custom frames. Also, what are the user wanted for glasses? So we make a survey with 600 people between 18 and 60 in the US, and what are the important features when the people buy new glasses? 1 is the optimal fit, 2 is the stability, and 3 is the weight. And we all match those things. So optimal fit we can have with our custom technology. Stability we have with the technology as well, and also the weight we cover. Also, we asked the question, what negative experience have you had with your glasses in the past? And the biggest point was the sliding on the glasses. This means we are working on technologies that the frame does not sliding on the nose. So the pressure marks are really important. This is due to the heavy weight and the uncomfortable fit behind the ears, because maybe optician or someone don't adjust it really correctly. So for that, we use the 3D technology. And also for the smart glasses, we have those problems because the weight with the past technologies, it's the weight of the electronics is a little bit heavier. So we have to have the lightest frame what we can have on the market to use this technology for smart glasses. What we see in the 3D printing benefits for smart glasses, first is imagine you can have an individual smart glasses configured with your mobile phone with a virtual try on, developed in 10 days and customized for a price for a standard frame. And the most benefits what we see, or the benefits, are the freedom of design. That means we can integrate the features like housing, interfaces, cables, everything really easy with our technology. We have a really durable material, so we don't need any metal core in the temples, and we have a really strong material also for the heat of the components of the technology for the electronic parts. We don't have a problem with it. Our frames are really lightweighted, so this is the main factor to reduce the weight in general for smart glasses. We have the customization, as said before, that we can have the perfect fit for everyone, that we don't have the problems with pressure marks or bad feelings behind the ears. And we're really flexible, so we don't need a mold. We don't have this the downs of the cutting technologies with the CAD standard cutting. So we can also use the cable where you can do the cable through the parts. So we don't think about the technology, to be honest. So we can do what you can imagine at the end. On the right side, you see a little bit how it could look like. So you see the smart hinge from OBE. And this is covered in a frame, in a possible design, and with the cable, and also on the back with a possible electronic thing. Yeah, I would say let's do the future of manufacturing, and let's work for it, that the smart glasses will look in the future like that on the picture, that it looks like a standard frame and don't have the ups or the downs of I would say the processes. So we will use 3D technology to enable it for the world.
So thank you very much for the part of UMAVO and the additive scale. Continue with the OBE part, and let's go in the small world of the SmartLink again.
Yes. Let's go back to the Smart Link and discover some extra features which are useful in smart glasses. The indicated dimensions cover the main constructions of current smart glasses with the cable feed-through. Especially the thickness of the cable channel was designed to fit all kinds of FPCs, ribbon cables, and so on, used in the smart glasses sector. But let's see more features.
So the feature number one is the cable shelter. As you can see it from the left picture, we simulated a cable feed-through situation without using the Smart Link. And the cable in this case could be easily damaged as it is open. And the Smart Link on the right side serves as a shelter to the cable from accidental contact in the open or even in the closed position. Next.
The Smart Link is also discrete in your frame and can be integrated easily in each design concept. The advantage, in fact, is not to see the hinge. All functions are inside.
So the feature number three is the movement control. So in the Smart Link, we implemented special screws which are plastic coated, called space screws. These screws are overmolded with a high temperature resistant polyamide. By assembling the Smart Link with these screws, we reach the desired movement control, as the plastic gives a regulation effect to avoid that the temple falls without any control on the front part. These patented space screws do not provide only a smooth articulation, but they have also an anti-loosening effect. The maximum length of these screws for the Smart Link is limited by 9.6 mm due to the machines in-house. So we have a maximum length of the screws, but we think we fit most of all smart glasses in this length already, or there are other solutions then.
Usually smart glasses are realized in plastic, or ideally, as we just heard, in 3D printing. For the optimum fixation, a metallic counter thread gives the best stability to the Smart Link and the space screws. This counter thing is provided by a special nut, as you can see here. As a result, the hinge can be assembled in all kinds of frame materials. The threaded sleeve fulfills the optimum connection. And a lot of customers might design really wide temples to fit to house their electronics. Since the Smart Link is limited to 6 mm due to the space screw limitation, it is possible to use a longer threaded sleeve to fit wider temples.
And the feature number 6 is related to stable end positions with pushers. As you can see in the animation, the feature optimizes even more the articulation. In fact, the Smart Link can be optionally equipped with 2 spring-loaded pushers that guarantee 2 stable positions of the temple, open and closed. You feel a kind of snap-in effect. In between the stable end position supported by the pushers, the plastic-coated space screws give the movement control. So you have 2 features. If you use the pushers, you have the snap-in effect, plus in between the space screws. If the frame shall be equipped with this feature, you see on the bottom of the slide on the right side, then there is obviously an extra space needed where you can see the dimensions.
And one of the biggest advantages of the SmartLink is the easy assembly and disassembly feature. Here you can see the assembling steps from the loose SmartLink, the inserting of the FPC, and finally the assembly with the 2 space screws and the nuts. This feature is very important as it enables, in case of a damage of the electronics, to replace or repair the electronics easily without disassembling the cables.
So summing up, seeing all the benefits of the SmartLink, it can be considered as a kind of universal plug solution for smart glasses. So we are prepared for the market to come. So anyway, thank you very much for attending, and
Thank you also.
see you next time, maybe on the 3rd webinar relating to smart hinges, smart glasses. Thank you. Bye-bye.
Thank you very much.
Thank you.
Bye.